Alright, so we are recording for chapter name energy. So what is work? So we'll first understand what is work. Okay. So basically whenever we read, write or work on a tab, okay, we say we are doing work. Even elders when they go to an office they work, they say they are doing work. But physics has a different definition for work. Do not consider this definition as work. In physics, work is said to be done only when a force is applied on a body and it makes the body move. All right, so there are two things. First, you have to apply force. So for example, this person is applying a force on this car and the car needs to move. Only then he has done work. Okay, so as per physics, there are two conditions for work to be done. One, force needs to be applied, and second, motion has to take place. Okay, there has to be some movement. For example, he's applying a force on a pedal and the bicycle is moving in front. So motion and force both have been working. All right, here bulls are applying force on the cart and they are moving the cart, so work has been done. So these are few examples of work done. All right, even some scenarios where you apply force, okay, still no work has been done. So for example, a person pushing a boulder, okay, and boulder is not moving, in that case no work is done, though he is applying a lot of force. A man applying a force on a tree, okay, now the tree won't move, okay, so in that case no work has been done. So you apply a force, you get tired, whatever you do, but the motion needs to take place. So here the man is applying a force on a wall, but we know this wall won't move, so even if he get tired, okay, he has done no work. All right, now what is energy? All right, so if you're applying force, or for example you're doing work over here, you're doing cycling, okay, that is you're applying force and motion is taking place. Or for example you are running, okay, so these are the examples of work. Now when you do this work, say for example you're doing cycling for 4 hours or you ran for an hour, in that case what will happen? You will get tired, okay, and if I ask you to run for, say again, can you cycle for 1 hour or can you run for half an hour, you will say no, I don't have energy. Okay, so what is energy? Energy is a capacity to do work. It gives you the capacity or the ability to do work. The amount of energy you have, that much work you can do. Now from where we get this energy? So whatever food we eat, from that we get this energy. For example, once if this person, these people are tired, once they'll have some food, take some rest, they can again do cycling for 4 hours and she can run for an hour. Okay, so we derive our energy from food. Okay, hence energy can be defined as ability to do work. So we get from energy we get the ability to do work. All right, now what is the relationship between work and energy? Now we saw that when you apply force and motion takes place, that is work, and if you keep doing work for a longer period of time, we get tired. And if I ask you to do the same work again once you are tired, it is not possible. So energy gives us the ability to do that work. Okay, so what is the relationship between work and energy? So more the energy you have, more work you can do. So without energy you can't do work, and more energy you have, the more work you can do. Okay, let us see some other relationship. Work is force into displacement. So the definition of the work is the force you apply and displacement takes place. Now the SI unit for force is Newton and that for displacement is meters. Now these two combined together we get joules. So there is a unit called as joule. It has been named after a scientist. So the SI unit of work is joules. Now the SI unit of energy is also joule. Now energy has another unit. Okay, it is not the SI unit, but mostly it has been used. It is called as calorie. All right. So what is the relationship between calorie and joule? So 1 calorie is approximately 4.2 joules. Okay. Now calorie is a very small unit. So a larger unit has been used, which is called as kilocalorie. So 1 kilocalorie is 4200 joules. Alright, we'll stop over here. Thank you.